Hey folks, here in section 7.3, we're going to do specific economic applications of area between two curves. So the knowledge we have right now on how to find area between two curves is going to be extended to some specific econ applications. So let's start off, as we always do, by looking at the objectives in this section. The first one is we're going to determine something that's called a consumer surplus. The second one is producer surplus. And then the third and final objective is computing consumers and producer surplus at what is called equilibrium. So let's start off by just kind of reviewing this beastie called the price demand function. The price demand function, P of X, gives the price at which people will buy exactly X units of a product. That's what we've been calling it so far. We've also seen that it can be called a demand function. So it's common to simply call the price demand function a demand function and then denote it with d of x, demand as a function of x. And I think in econ, they tend to do more of the d of x variety, demand function. Let's look at a typical demand curve. So here's a typical demand curve over here to the right. And typically speaking, and generally speaking, a demand curve is an always decreasing function. Notice how as you move from left to right, the curve is decreasing. And that should make sense. It's decreasing because as the price decreases, the demand for whatever item we're talking about will increase. So think about this from the typical consumer standpoint. As the price goes down, consumers are going to buy more. Price goes down, I tend to buy more. People buy more. So that's the basics to get us started here in section 7.3. And to make sure we understand this, let's do a quick example. John Snow Tires, well, they're selling some all-terrain tires. For a certain week, their popular Stark series has a demand function given by d of x equals negative 1.7x plus 275.50. X is the quantity demanded that week, and d of x is the price per tire. We're going to compute d of 30 and d of 51 and interpret each. So you know what I'm going to do now? I'm going to head off to the chalkboard to work out this example. And then after we work out this example, we'll continue on trying to make sense out of what is called consumer surplus. Hey folks, the example we just saw, John Snow Tires sells all-terrain tires. And for a certain week, their popular Stark series has a demand function given by this. And X is the quantity demanded that week, and D of X is the price per tire. You were asked to do two things in this example: compute D of 30 and D of 51 and interpret each. So here we go, D of 30. Well, you know, to do D of 30, you toss 30 in for X, and when I do that, fire up my calculator, I get 224.5, which simply means when 30 tires are demanded, the price is $224.50 per tire. For D of 51, well, here we take 51, toss it in for X, and when I do that and crank it through my calculator, I get 188.8. So that just simply means when 51 tires are demanded, the price per tire is $188.80. And intuitively, that would make sense that when more are demanded, the price is going down. This is from the consumer standpoint. From the consumer's perspective, and I'm a consumer, when I see the prices coming down, I'll be more likely to buy it. So what we're going to do now is we're going to head back to the slides and continue our process in trying to make sense out of what is known as a consumer surplus.
So we're going to go look at some slides. We're going to see some graphs, and then we'll be looking at an example. We'll come back here and do another example.
All right, here we are. Let's continue on with that tire example. Now let's just do a what if. Suppose you were going to buy the tire for $250. So it's like, you like the tire, you're willing to spend $250 for it. You show up and you see that it currently costs $188.80. That should make you happy. Makes you happy, and we say in that sense that you've, quote, saved $61.20. I mean, you were willing to pay $250, but you got it for $188.80. So it's kind of like, yeah, you saved $61.20. Now consider that's what it's currently selling for, $188.80. Let's consider any price above that $188.80 that any consumer is willing to pay, minus the actual price that's $188.80. So let's say my friend Joe, he'd be willing to buy it for $200. Well, he's still, quote, saving some money because it's $188.80. So the example I just gave you, Joe, he's saving money. It's the price he was willing to pay minus the actual price. So that's for any other consumer. Now let's say for all these consumers out there that were willing to pay more than $188.80, all of them are getting a savings. When we add up all those savings, the sum of all those savings is known as the consumer surplus. So if you had 5 people and all 5 people were willing to pay more than $188.80, whatever they were willing to pay, you take that price, subtract the $188.80. That's what each individual consumer would have, quote, saved. You add them all together, and that gives the cumulative. It gives the total consumer surplus for that tire. In general, the consumer surplus, what it does, it measures the benefit that consumers like us, it's the benefit that we get from being in an economy where there's competition, because that competition will help keep prices down. And again, I know this is a lot of econ here. This is really, purely econ, but hopefully you've seen this in a prior econ course, the benefits of competition, or when you do take an econ course, you're going to hear the benefits of competition. So now that we know what consumer surplus is, here's a little bit more mathy type definition. The consumer surplus is the total amount saved by consumers, all consumers, who are willing to pay more than the market price, and I'll denote market price as D sub MP. So that's just how I'm representing market price for a product, but they're able to purchase the product at market price. So whatever the market price is, if you were willing to pay more for that, but you can buy it at market price, you're receiving a surplus. You're receiving a, quote, savings. So the consumer surplus, and you notice it's an S apostrophe, that means all of us, is the total amount. It's adding up all of it. So you kind of know where this is going to eventually go. We're adding up a bunch of stuff. Eventually, we're going to see integration take place. But before we get there, let's look at the tire example one more time. I have 2 graphs here. The graph that's on the left, that shows how much consumers spent on 51 tires. So, say 51 people each bought 1 tire. So it's the amount that was spent. That's called the actual consumer expenditure. And you could find the area of that rectangle by basically taking 51 times 180.80. So that was how much those 51 consumers spent on 51 tires at a market price of $188.80. Now look at the graph on the right. The graph on the right, that little triangular region that's shaded, it shows the total amount consumers saved, quote, saved during the sale of $188.80 for the tires. So that total amount that's saved, that is the consumer surplus. And I can't stress enough this shaded region right here, the region that is between the demand function and price, the region that is between demand and price, that region is consumer surplus. And as you can clearly see, this region that's representing consumer surplus is an area between two curves. It's between the demand curve and it's between the line or the curve given by market price. So how do we find the area between two curves? Well, for any demand function D and point x sub n, d sub mp that's on the graph of D, and x sub m just represents market demand, and we already saw that d sub mp is the market price, we get the consumer surplus. Since we saw it's a region between two curves, we're going to get it by integrating the top curve minus the bottom curve. Top curve minus bottom curve. And notice the limits of integration are 0 to market demand, x sub m. So top curve minus bottom curve. It's just like we saw before on how you find area between two curves. So let's look at an example. Given the graph to the right, let's determine the area of the shaded region and interpret. Folks, this is a demand curve. This is price. The area between the curves is going to be the consumer surplus. And one more time, how do you find the area between the curve? Well, you're going to integrate from 0 to 51 the top curve minus the bottom curve. But let's head off to the chalkboard and work through this example to see what we end up getting. So here we go to the chalkboard.
Hey, the example we just left off with, there was a nice graph there, and it said for the graph to the right, determine the area of the shaded region. So what I tried to do was quickly sketch what that graph looked like. Well, my sketch isn't going to be as pretty as what you just saw on the slide, but it has the important features. This was the demand curve. Market price is $188.80. Market demand is $50. This shaded region, the area that is shaded, the region that is between the demand curve and market price, that is consumer surplus. So what I want you to remember, and this will come out later on in the video, always remember that the region between demand curve and market price, that region is consumer surplus. Remember, demand curve pertains to us, the consumers. So that's the consumer surplus. So finding the area of this region, that's just old calculus, finding the area between two curves. So to find the area between the two curves, I simply need to integrate from 0 to 51, from 0 to 51, that's what the region is bounded by, the top curve, and the top curve is the demand curve, negative 1.7x plus 275.50 minus the bottom curve. Here the bottom curve is just simply, well, 188.80. And we're integrating with respect to x. Let me kind of break that off a little bit. So to do this, I'm going to start by simplifying the beastie that I'm trying to integrate. In other words, it's a negative 1.7x, 275.50 minus 188.80. I combine those together and I get 86.7. Now I go through the calculus, get an antiderivative. So the antiderivative of the first piece here, that's using our old power rule. It's negative 0.85x squared. Antiderivative there is 86.7x. Evaluate that from 0 to 51 using the fundamental theorem of calculus. And I get 2,210.85. That is the consumer surplus. So a short, sweet interpretation would be the consumer surplus is $2,210.85. That's all there is to consumer surplus. It's just area between curves. To make sure you have the concept down, you know how to find the area between curves, and you know what I'm going to want you to do. You know, I'm going to want you to try one of our homework problems. So I'm going to have you pause the video and try number 19 here in section 7.3. So go ahead, pause the video, try number 19. After you've done number 19, restart the video, and I'll be here at the chalkboard cranking through the solution. All right, A and 19, you were asked to find the consumer surplus given this demand function and given demand level x equals 150. Okay, now in order to do this, in order to get the consumer surplus, I'm given the demand level, that's the quantity that's demanded. I need to determine what the market price is or what the demand price is. So to get the demand price, I have to start by evaluating the demand function at 150. So I have to toss 150 in here for x, crank it through, and I get the demand or the market price. When I put 150 in there, I get it to be 510. So that's the market price, demand price. Now I should be able to set up the integral that's going to determine consumer surplus. It's the integral from 0 to 150, the demand. 0 to 150, the demand function minus the market price, 510. And just like we saw in the example, I begin by cleaning this up. 600 minus 510 is 90. So I'm integrating a negative 0.6x plus 90 dx. And let's see, I get an antiderivative here. Antiderivative is negative 0.3x squared plus a 90x. I evaluate that from 0 to 150. So I use my fundamental theorem of calculus, evaluate it from 0 to 150. And when I do that, I crank it through my calculator, I get 6,750. So that means, quite simply, the consumer surplus is $6,750. That's it. Hope you got it. Hope that makes sense. Hope you're getting a good handle here on consumer surplus. Remember, that pertains to us being consumers. Now we're going to head back to the slides and we're going to look at this scenario from the viewpoint of the supplier. And we're going to end up, the people that supply the items, we're going to call them producers. They're producing the items that we consumers are buying, and that's going to eventually lead us to what is called a producer surplus. So let's head back to the slides and let's look at things from the perspective of the supplier.
All right, hey folks, after working through that example and then doing number 19, hopefully you have a better handle now on computing consumer surplus, and you see it's nothing more than area between curves, and it's nothing more than integrating top curve minus bottom curve, integrating demand minus price. So now we're going to switch gears and look at things from the producer standpoint. For producers, they have a special function. It's called the supply function. And the supply function, S, for any product, it's going to give the price, S of x, at which exactly x units of the product will be supplied. Here's the graph of a typical supply curve. A typical supply curve, in general, it's increasing. And that should make sense. You know, this is from the producer standpoint, the people that are making, say, the tires we're talking about, the producers of these tires. that as the quantity demanded, you know, it's increasing as the price is increasing. I mean, think of it from their viewpoint. When the price goes up on an item, they're going to supply more of the item. They want to sell more at the higher price. So let's see what we have cooking now, making sure we understand the supply side of things. Still dealing with the same tire example, but now let's say the supplier of the Stark Series tire, they have a supply function given by S of x equals 2.5x plus 45.5, and x is the quantity supplied each week, and S of x is the price per tire, and it's in dollars. So let's compute the S of 20, the S of 60, and let's interpret each. So, write it down if you need to, because I'm heading off to the chalkboard to work through this example.
All right, hey, we saw in this example, we're continuing the discussion about these tires that started us off in the consumer surplus. In this example, it said, suppose the supplier of the Stark Series tire has a supply function given by S of x equals 2.5x plus 45.5. And here, x is the quantity supplied each week, and S of x is the price per tire in dollars. You're asked to do two things in the example. Compute S of 20 and S of 60 and interpret each of those. Well, if we start off doing S of 20, we're going to put 20 in there for x. See what comes out. Out comes 95.5. Quite simply, that just means that the supplier will supply 20 tires where the price of each tire is $95.50. The S of 60, okay, now I expect this to be a larger number. I mean, think about it. The supplier, if the price is higher, the supplier will want to supply more of them. And if we put 60 in here for x, what comes out is, oh boy, 195.5, which tells us, the interpretation, that the supplier is willing to supply 60 tires where the price of each tire is $195.50. So think about this. This should make sense. If the prices are higher, of course the supplier will supply more of them. If I'm selling something and the price goes up, I want to get more of them out there so I can make more money. So that's our introduction here to what's happening from the supplier side of thing, the producer side of thing. So what we're getting ready to do now is we're going to head back to the slides. We're going to now use this to kind of make sense out of what is known as the producer surplus. And then I'm sure we'll look at an example. We'll come back here to the board, chalkboard, work through the example, and hopefully it's all making sense. But let's head back to the slides.
Okay, as we saw in that example, when the quantity demanded was larger, corresponded with the higher price. That, at a price of $195 per tire, the supplier is going to supply 60 of them, but at only $95 per tire, they were only supplying 20 tires. Intuitively, that makes sense. With a higher price, suppliers are going to supply more. Now, if we continue on with this tire example, let's say we're continuing where the current market price is $188.80. Now, let's play the what if game. Suppose the supplier, agrees to stay in business. If the price happened to drop to $150, okay, that means any tire that's sold for more than $150 would be a, quote, gain for the supplier of $38.30. So any price below $188.80 at which the supplier is willing to supply the tires, subtracted from that $188.80, let's consider any of those prices. The sum of all of those gains over that price that's below $188.80, that's what's called the producer surplus. So we've already seen the consumer surplus is kind of what it pertains to us, the consumers, and the benefit we get from competition in the market. So the producer surplus, kind of think of it as, okay, I'm willing to stay in business. I'm willing to supply this item. If the price drops to a certain point below what the current market price is, and then any difference from that point to the market price, you add them all up and you get yourself the producer surplus. So a little bit more mathy of a definition. The producer surplus is the total amount gained by producers who are willing to receive less than the market price, but yet they're able to get market price. So in the prior slide, market price was $188.80, but they were willing to receive $150. Let's look at a picture. Still on this tire example. The graph on the left, that's showing how much the total amount the producers would receive. So now this is when they were supplying 60 tires. Supplying 60 tires where the price was $195.50. So that rectangle, you can find the area of that rectangle. They're selling 60 at a price of $195.50. Let's see, price times quantity, that's actually revenue. And look, I even have it here in parentheses, revenue. Look at the graph on the right. That little triangular region is shaded. The graph on the right shows how much the supplier made over what they were willing to receive. That's the producer surplus. And again, notice both of them are at a quantity of X equals 60. So let me stop here before I go to the next slide. This is the producer surplus. Please remember, producer surplus is area of a region that's between the price and the supply function. If you remember, supply function pertains to producers. The region that's between price and supply is the producer surplus. And hopefully you see where this is going to go. It's finding the area of this region, that's the area between two curves, 195.50, the price, and the supply function. So hopefully you're anticipating an integral is going to be set up. So for any supply function S and point X sub n, D sub MP, remember X sub n is market demand, D sub MP is the market price. We get the producer surplus by integrating from 0 to market demand, X sub n, M, the market demand, the market price minus the supply function. That's the area between two curves. Market price minus the supply function. I'm sure we have an example here. For the graph to the right, determine the area of the shaded region and interpret. So here's what pops into my head. I have a supply function. There's my market price. This area that's between market price and supply, the area of that region is nothing more than producer surplus. How do I find the area of this region? Well, it's between two curves, so I should integrate. I should integrate from 0 to 60, the top curve, minus the bottom curve. So let's head on up to the chalkboard and crank through this to see what the producer surplus is.
All right, this example we're asked, we were said, given the graph to the right, determine the area of the shaded region and interpret. Here's what I want you to know. Look at the area of the shaded region. This region is the region between the market price and the supply function. Supply function, the supply function pertains to the producers of whatever the item is. So the area that's between the price and supply, that area is going to be the producer surplus. Remember, for a demand function, the area between the demand function and price was the consumer surplus. Area between supply function and price, that's the producer surplus. So all we have to do is find the area of that region That will tell us the producer surplus. This is an old calculus problem, finding area between two curves. So to find the area between those two curves, we just simply integrate from 0 to 60. It's going from 0 to 60. That's the x values that the region's bounded by. Top curve, the top curve is 195.50 minus the bottom curve. And the bottom curve was the supply function. And the supply function, I didn't write it up here on the board, but the supply function was 2.5x plus 45.5. So I start by just cleaning up my integrand. I distribute that -1, combine like terms, and I get a -2.5x. Let's see, 195.50 minus 45.5 leaves me with, well, that's kind of nice, 150. Do some calculus now, I get an antiderivative. The antiderivative is -1.25 x squared plus 150x. I evaluate that from 0 to 60. So I crank it through the good old fundamental theorem of calculus, and out comes 4,500. So keep in mind, all that is the producer surplus. I mean, this is just telling us that the producer surplus is $4,500. So I'm going to want you to try one of the odd numbered problems now to make sure that you have the process under control. So what I'd like you to do is pause the video and go ahead and give number 33 a try. So pause the video, try number 33. When you're done with number 33, restart the video, and I'll be here at the chalkboard cranking through the solution. Alright, and number 33, let's make sure I'm reading it correctly. You're asked to determine the producer surplus for the given supply function and demand level X. So, the first thing we're going to have to do is we're going to have to determine, the market price. You're going to get the market price by tossing 60 in for X. So toss 60 in for X and you get the market price to be 75. Producer surplus is area between the market price and the supply function. Market price and supply function. So it's just simply integrating from 0 to 60, market price, and then minus the supply function. And what I tend to always do is clean up the integrand before I start the calculus. And I get a -1/3 x, 75 minus 55 is 20. Now I can do my calculus, get an antiderivative. So the antiderivative of this mess is a -1/6 x squared plus a 20x. And I evaluate that from 0 to 60. So I use my fundamental theorem of calculus to evaluate that, and I get 600. So that means, quite simply, the producer surplus is $600. $600 each month, I guess. I don't know. Hey, I hope you're understanding how to find the producer surplus and how to find the consumer surplus. We're going to head back to the slides now. We're going to talk about this magical point that occurs in the wonderful world of economics. It's the point where the demand function, remember your demand function is an always decreasing function, and the supply function, which is an always increasing function. We're going to talk about that magical point where those two curves, supply and demand, intersect. So we're going to go off to the slides, talk about this magical point, which is going to be called an equilibrium point. And then after we look at that slide, I think we'll have one more example left. So let's head back to the slides and talk about the magic of the equilibrium point.
All right, hey folks, so we did that example. We computed the producer surplus, and then I asked you to do number 33, practice finding another producer surplus. So before going on, just going to reiterate one more time. The region between demand and price is consumer surplus. The region between supply and price is producer surplus. So now we're going to talk about a special point in econ theory. It's the point where the supply curve and the demand curve intersect. In other words, where d of x equals s of x. That point is called the equilibrium point. And the equilibrium point has x and y coordinates. The x coordinate will be called equilibrium demand. The y coordinate will be called equilibrium price. I mean, it's still demand and price, but since it's at equilibrium, it has the special name equilibrium demand, equilibrium price. Let's look at one handy dandy picture here. This picture has everything on it. Notice the blue curve is the supply function. The red curve is the demand function. We've labeled where the two curves intersect as the equilibrium point. That means the x-coordinate, down here, the x-coordinate is equilibrium demand. The y-coordinate, that's equilibrium price. The region that is between the demand curve and price, that region is consumer surplus at equilibrium. The region that's between the supply curve and price, that's the producer surplus at equilibrium. And it's easy to find area between two curves. It's always integrating the top curve minus the bottom curve. So I bet we have an example here. And it's our good old tire example. So what we've been seeing so far through the slideshow and all the examples is we have this tire. The demand for the tire is given by d of x equals negative 1.7x plus 275.50. The supply function is given by s of x equals 2.5x plus 45.5. And here we're going to do two things. In part A, we're going to determine the equilibrium point. So we're going to determine where demand intersects supply, where demand is equal to supply. Keep in mind, when we find the equilibrium point, the x-coordinate will be demand, the y-coordinate will be price. The x-coordinate will be equilibrium demand, the y-coordinate will be equilibrium price. And once we've determined the equilibrium point, well, in part B, we'll go ahead and compute consumers and producer surplus at equilibrium demand. And that will conclude the section. So let's head on off to the chalkboard and do this example.
All right, hey, on that one slide talking about equilibrium point, we had a lot of stuff there. We had the demand curve sketched in, we had the supply curve sketched in, we had equilibrium point labeled, we had a region shaded that was telling us the consumer surplus at equilibrium, a different region shaded talking about producer surplus at equilibrium. The equilibrium point's an x-coordinate and a y-coordinate. The x-coordinate is equilibrium demand. The y-coordinate is equilibrium price. And one more time, hopefully you're seeing the region between demand function and price is consumer surplus. The region between supply function and the price is the producer surplus. So in this final example here, we're still talking about this tires, the Stark Series tires that has been motivating everything in this section. The demand function for the tire was that. The supply function was this. In part A, you're asked to find the equilibrium point. So to find the equilibrium point, that's where these two curves intersect. So, we can do that algebraically. Where do the two curves intersect? Well, you just set them equal to each other. Negative 1.7x plus 275.50 equals 2.5x plus 45.50. Okay, we just have to solve this equation for x. So what I would do, I'm going to do two steps at once. I'm going to subtract 45.5 from both sides of the equation, and I'm going to add 1.7x to both sides of the equation. So subtracting 45.5 from both sides of the equation gives me 230. Adding 1.7x to both sides of the equation gives me a 4.2x over here. Divide both sides by 4.2 and I get x is pretty close to 54.76. Okay, now folks, we're dealing with tires here. We can't have an x value. Remember, x is the quantity. It's either the quantity demanded or quantity supplied. We can't have a decimal part. No one's going to buy 3/4 of a tire. So we're going to take this and round it to the nearest whole number. So let's round it to the nearest whole number, which will be 55. And now we need to get the y value. So we can take this and toss it into either one of these functions for x to get a y value to come out. And I get the y value of 183. So the equilibrium point, it is a point. It has an x coordinate and it has a y coordinate. This is equilibrium demand. This is equilibrium price. Part B, we're asked to find the consumers and producer surplus at the equilibrium demand. I'm going to have to erase the board so I can do part B. So I'm going to erase the board so we can do part B, get the consumer surplus and the producer surplus. But please remember, this is the equilibrium demand, this is the equilibrium price. I'm going to need those values when I find my consumers and producer surplus. So I'm going to erase the board now, and we'll get on with part B. You know what, I'll just leave that over there so I don't have to try to remember it. Part B. Let's start off in part B of determining the consumer surplus. So the consumer surplus would be found by integrating from 0 to 55. 0 to equilibrium demand. It's the consumer surplus. So it's the demand function minus the price. Demand function minus the price. And like I always do, I clean up my integrand before I start the calculus. And I get a negative 1.7x. See, 275.50 minus 183, that's 92.5. Get an antiderivative, negative 0.85x squared plus a 92.5x. And I evaluate that from 0 to 55. So I crank it through my fundamental theorem of calculus, and I get 2,516.25. So my consumer surplus at equilibrium demand is $2,516.25. I'm going to have to erase this so I can do the producer surplus. So if you have to pause it to write anything down, please do that because it's going to disappear. Producer surplus at equilibrium demand. Well, producer surplus at equilibrium demand, it's integrating from 0 to 55, the equilibrium demand. Price minus the supply function. So the price is 183 minus the supply function. And you know what I'm going to do. You know I'm going to clean up my integrand before I go any further. So I have a negative 2.5x, and 183 minus 45.5 leaves me with a 137.5. Get my antiderivative, negative 1.25x squared plus 137.5x. Evaluate that from 0 to 55. So I use my fundamental theorem of calculus, and I get $3,781.25. So the producer surplus at equilibrium is $3,781.25. All right, so I hope this is making sense. I strongly encourage you to read this section as well. It gives the section itself, the text is talking about bicycles, but it gives the same type of treatment. It's one product all the way through from the consumer's and producer's standpoint. But hopefully it's making sense. You're ready to go attack the homework problems now? So get on, go do the homework problems. And thanks for watching.